All right, how's everybody doing today? It's Mr. Masseroni. I'm going to be going over page 42 of the classwork packet. We're talking about similarity. Are the following pairs of triangles similar? If they are, then name their similarity criteria. Side, 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 side angle, side, or angle, angle. Okay? I'm going to do these a little out of order just because it works out better for me, easier on the paper. All right, so this first one, A, we're looking at, see how we've got right angles, and then we've got the same marking here, so that's going to be a yes, because we have angle, angle. Now if you look at D, okay, what I'm looking at are parallel lines. Now when you have parallel lines, you have what's called corresponding angles, so those are the same. Technically these are also the same. And this angle's in both triangles. So we're going to say yes, and all we really have to say is angle, angle. All right, now I'm going to move on. And what we need when we see these measurements are proportions. We're going to look at all the proportions. So if we do largest side over largest side, 8 over 4, we get 2. And then the next largest, 7 over 3.5. And we also need 5.6 over 2.8. And what I'm going to do here, put that right here on the calculator. 7 divided by 3.5, we get 2. 5.6 divided by 2.8, we also get 2. So these are all 2. So they are in the same proportion. So yes, side, side, side. Okay, now move on to E. We look at it, we don't have the same angle. These two sides are the same. These two are the same, but we've got nothing else. So nothing there matches up. If these two angles were the same, okay, we could conclude, because these are both isosceles triangles, that these would be the same. It would be angle, angle, but because these are different, we have a no. All right, now we're going to move on. Now here we're looking at our angles. So if I look to try to find the third angle, I'm going to do 57 plus 53, and I get 110. 180 minus 110 is 70. So we've got 57, but it doesn't look like the others are going to line up, so that's going to be a no. All right, and then this one here, F, we've got these angles. We've got an X and a theta. They don't line up. They're not the same. That's a no. All right, now we're going to move on down here. Are the following pairs of triangles similar? Same thing. If yes, name the similarity, side, 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 side angle, angle, and create a similarity statement. If no, just say no. So let's see. We're going to look at this first one. We've got 63 and 21, 63 and 96. So I'm going to do 96 plus 63. And I get 159. 180 minus 159 is 21. So that would be 21, which matches here. So I'm going to say yes, angle, angle. And now I've got to do my similarities. The 63s line up. Okay, these 21s line up. So I'm going to do E, F, D, F, D. And then over here, R, H, G. R, H, G. And that's what we have. All right, now again, I'm going to move down here. Looking at C. We've got this angle here. This line, it doesn't tell us if it's a midpoint, doesn't tell us if it's parallel. We can't assume anything. So that's going to be a no. All right, now we come down here, E. Now we've got isosceles triangles. So when you look, isosceles triangle, that's 77. This is also going to be 77. So when you add 77 and 77, you get 154. If you do 180 minus 154, you get 26, which is exactly what we have here. Now, because these are isosceles, you're also going to have your 77s here. So this is a yes, angle, angle, okay? And my similarity statement, this C is going to line up with S. So I'm going to do C, B, D, and S, T, R. Okay? Now for G. All right, we've got a right angle, and we've got 3 and 4, 6. We don't have anything for the 4, but we've got a 10 here. So what I'm going to do is I'm going to actually do the Pythagorean theorem here. 3 squared plus 4 squared is going to equal, I'm going to call that x squared. So we get 9 plus 16 is x squared. 25 is x squared, so x is 5. Now, if we do 10 divided by 5, we get 2. We do 6 divided by 3, we get 2. And it looks kind of like I did that a little out of order, so I'm going to do another Pythagorean theorem here. 6 squared plus, I'll call this y squared equals 10 squared. So 36 plus y squared is 100. And then y squared is 64, so y is 8. So that's going to be 8, so we'll do 8 divided by 4 is 2. Now, either one works, side, 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 or side, angle, side. So I'm going to say yes, side, 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 or side, angle, side. And then it's going to be F, B, R is congruent to Z, G, Y. Those are the sides that line up. All right. I'm going to move over here to B, move this column. Now I've got parallel lines. So what we're going to look for is alternate interior angles. Okay, so you see my parallel lines are here. This angle lines up with this angle, and then here we've got vertical angles, so that's going to be yes. Criteria is angle, angle, SQR and GQT. All right, now D, we've got all these proportions, and I'm going to line them up. The largest one, 9.9 divided by 8.25. We've got 6.6 divided by 5.5 and 4.8 divided by 4. Bring the calculator in, see what we get. 9.9 divided by 8.25. 1.2. 6.6 divided by 5.5. 1.2. 4.8 divided by 4, 1.2. So that works out very well. These are all 1.2. So that's a yes, side, side, side. And I'll line them up. NOP and TRH. All right. Now I'm going to move on to F. Last one here, we've got parallel lines. Okay, so what I'm going to look for again is alternate interior angles. That angle lines up with that angle, and then on the other side, that angle and that angle. So we're going to have yes, it's going to be angle, angle, and it's triangle EFG and triangle GH. E. And then the last one, H. Now if we look, this angle is in both triangles. These angles are the same. So I'm going to say that's a yes, angle, angle. And it's triangle LMN and triangle LJK. Okay? And there you have it. That's page 42. I'm going to follow up with page 43 next. Hope everybody's doing okay. Thanks and good luck.